Hi, PropStat students. This is a quick review of the core content that you need to be successful with Project 1 on food. In a bar graph, you can display qualitative data. Qualitative data is data that are not numbers. So in this case, we were talking about activities during somebody's day. So this student slept 8 hours, went to school for 6 hours, they were eating for 1.5 hours, and they put everything else together as other for 8.5 hours. Bar graphs show the count on the y-axis. So the hours were counted on the y-axis and the category on the x-axis. So sleep, school, eating, other, those categories are on the x-axis. The graph must have a title here, and each axis must be labeled: activity, count of hours. Another way to show qualitative data is in a pie chart. Pie charts show the rates or the percentages. So you can see that we found the percentage of the day spent on each activity by dividing by 24 hours in a day. So 8 hours divided by 24 gave us 0.33, or 33% of the day spent on sleep. 6 divided by 24 gave us 0.25, or 25% of the day spent on school. 1.5 divided by 24 gave us 0.06, which is just 6% of the day eating. And then the rest of the day was 8.5 divided by 24, which is 35% of the day on other activities. Pie charts show the rates or the percentages. So even though both bar graphs and pie charts display qualitative data, the bar graphs display the counts and the pie charts display the rates. So you'll see that here. Pie charts must also have a title, and they either need to have a key or they have to have the labels, the categories labeled here and here. And they have to display the rates. So this pie graph actually shows 33.3% underneath sleep and then also on the pie graph. One way to show quantitative data is in a dot plot. Dot plots display quantitative data, which would be numbers. So in this case, the categories are the numbers of goals scored. Dot plots have a title and an X label axis. So in this dot plot, you can see that 3 people scored 5 goals in the season. 1, 2, 3. Okay, other graphs. A stem plot shows quantitative data, and it's similar to a rotated dot plot. So if you think of the leaves here, the 4, 4, 5 as dots, it could be like a dot plot. The stem is all of the digits except for the final digit. So to put the number 150 here, the stem was 15, and then the leaf is the final digit 0. If you look at the first row here, this represents 3 different numbers: 34, 34, and 35. And here's your key. Pictograms are another type of graph, but they can be misleading. So think about how this graph is misleading. Pause for a second and think about that. It looks like Shayna at Halloween, she got between 16 and 20, so probably she got 18 pieces of candy. Michael got 36 pieces of candy. And so that means Michael got twice as much candy as Shayna. However, because the candy corn has both height and width, it actually appears more than twice as big as Shayna's candy corn. Let me show you. Here is one that's the size of Shayna's candy corn. I can put it here. Here's another one the size of Shayna's candy corn. And here's another one, and there's even some gaps between these candy corns that would probably put together even more. So Michael's candy corn, even though he only got twice as much candy, it looks like it's more than 3 times as big. And expectations for all graphs. Label the title and the axes. The scale should be uniform and appropriate, which means you can count by twos. You can go 2, 4, 6, 8. You can count by fives, 5, 10, 15, 20, but you can't switch up your scale. You can't go 2 and then 7 and then 8 and then 15. You have to have the same scale. And it has to be appropriate for your data. If your data are between 1 and 10, then you're not going to count by 20s because everything would be in the first section. Your graphs should be created with software when you do your project. And when you do your project, you will analyze each graph with 3 complete sentences. And that is it for your quick overview, but do make sure that you also did your Edpuzzle.